Welcome to this explainer. Today we're doing something absolutely crucial. We are visualizing the foundational building blocks of economic principles. Look, if you've ever found yourself wondering why the world works the way it does, why things cost what they do, or why we just can't have absolutely everything we want all at once, well, it all boils down to the core concepts we're about to unpack right now.
Okay, let's dive into this roadmap. We'll be speeding through scarcity and choice, the factors of production, classes of goods, production possibilities, growth and tech pivots, and finally, we'll wrap up with the science of economics. Right, kicking things off with Section 1, Scarcity and Choice, the universal problem. So here's the ultimate dilemma that drives every single economic decision ever made. Notice the stark contrast here on screen. On one side, human wants are completely subjective and constantly shifting. It's like a moving goalpost, right? You satisfy one desire, and bam, another one pops up. But facing that is a really harsh reality. Limited resources. The physical, actual means we have to satisfy our endless desires are finite. Because we can't literally have it all, this tension forces us to do something very specific. We have to make choices.
And so the crucial point is that choosing one thing automatically means sacrificing another. In economics, we call this opportunity cost. It is literally defined as the value of the best alternative foregone when a choice is made. Notice that specific word, foregone. If you choose to spend your evening studying, the opportunity cost isn't just the money you didn't spend, it's the value of the fun you foregone by not going to the cinema with your mates. Every single choice carries a hidden cost.
Moving right along to Section 2, factors of production, inputs and returns. Let's look at the actual ingredients society uses to solve this problem. Everything produced in an economy stems from these four exact categories of inputs, and each one comes with a very specific financial return. First up, we've got land, which actually represents all natural resources. The return for land? That's rent. Next is labor, the human effort which naturally earns wages. Then we have capital. And quick heads up, in economics, capital doesn't just mean money. It means machinery, tools, and intermediate goods used to make other things. The return on capital is interest. Finally, entrepreneurship. This is the risk-taking and organizing skill that brings the other three together, and that earns profit. All right, let's shift our focus from the inputs we use to the outputs we create. In Section 3, classes of goods, categorizing outputs. Economists love categorizing things to make sense of the world. For instance, we distinguish between consumer goods, like the bread you grab for breakfast, and capital goods, like the massive industrial oven the bakery used to make it. We also look at lifespan, durable goods, like a heavy oak table, versus non-durable goods, with a single use, like your lunch. We separate free goods, like seawater, which carries no direct price, from economic goods, which absolutely do. Then there are public goods provided for everyone, like street lighting or local parks. And we even categorize by how consumers perceive them. Homogeneous goods, which are virtually identical, versus heterogeneous goods, like different brands of running shoes that compete on totally unique features.
Now for the really fun stuff. Section 4, Production Possibilities, Visualizing Trade-offs.
This right here is arguably the most important mathematical model we use to analyze these concepts in action. Notice the specific concave shape of this production possibilities curve. It is distinctly bowed out from the origin. Why? Because this visually represents the law of increasing opportunity cost. Essentially, as a country decides to shift its resources to produce more and more capital goods, it has to sacrifice increasingly larger amounts of consumer goods to do so.
Now, look at the precise positioning of the points anchoring this curve. Any point sitting exactly on this line represents absolute economic efficiency. If you are operating directly on this line, you are perfectly maximizing your output. You literally cannot produce more of one good without giving up some of the other. But what happens if we look at the empty space inside the curve? Well, producing anywhere in this internal area means we are suffering from inefficiency. It tells us we have idle resources. Maybe factories are sitting empty or there's a high rate of unemployment. The tragedy here is that we could easily produce more of both goods just by putting those idle resources back to work.
Conversely, any point sitting entirely outside the boundary, that's just a dream right now. Given her current limited stock of resources and our current technology, it is physically impossible to reach a point out there.
So, to quickly summarize these vital spatial rules, on the curve means efficient. Inside the curve means inefficient, basically unemployed resources, and outside the curve means unattainable. Grasping these specific positions is absolutely key to reading this model like a true economist. Let's jump to Section 5,
growth and tech pivots, dynamic changes over time.
So how do we actually reach those previously unattainable points outside the curve? We need the entire boundary to experience an outward shift. When the whole curve shifts outwards, it represents true economic growth across all sectors. This magic happens when a society suddenly gains more resources or experiences a massive overall improvement in productivity, allowing it to produce way more consumer and capital goods at the exact same time.
But contrast that full shift with a swivel or pivot. Imagine a new form of specialization or a technological change that only improves efficiency for one specific good. Let's say a revolutionary new tractor is invented. Our ability to produce agricultural goods expands outward along that specific axis, but our capacity to make completely unrelated goods, like computer software on the other axis, stays anchored right where it was. The curve doesn't shift entirely, it just pivots.
Which brings us nicely to our final building block, Section 6, Science of Economics, Rules for Analysis. Because economists deal with massively complex real-world variables, they have very strict rules to keep things accurate. First, we must draw a definitive line. We have positive statements, which are objective, testable facts that can be proven right or wrong. Then we have normative statements, which are purely subjective, based entirely on opinions, feelings, or value judgments about what ought to be. The golden rule here? The science of economics relies entirely on positive statements to build its theories. Leave the opinions at the door.
And finally, because the real world is incredibly messy, with a million things changing all at once, economists need a way to isolate cause and effect. The assumption visualized here on screen is our scientific anchor. This specific rule means all other things being equal. It allows us to essentially freeze reality, holding every other complex variable completely constant, except for the single one we are actively studying. It's really the only way we can accurately analyze relationships between two moving parts without getting completely lost.
And there we have it. We visualized the core foundations, from the harsh reality of scarcity right through to the sophisticated models of production possibilities. But, the beautiful thing about these principles is that they aren't just for textbooks. They apply directly to you. So I'm going to leave you with this provocative thought. Now that you have the tools, how will you analyze the opportunity costs of your own daily choices? What are you truly giving up when you make your next big decision? Keep that in mind and keep learning. Catch you next time.